Good morning. This lesson is for my Integrated 1 classes, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of are two goals for the day. Our first goal is going to be to create equations that represent tables, and our second goal is going to be to verify that the equations work. So in the previous lesson, we saw how to rewrite tables with repeating numbers. We're going to use the repeating numbers to help us write equations that represent tables. So we're going to start this lesson by rewriting a table with repeating numbers. So just to review to make sure we're all on the same page. Now I'm not going to show everything we did on the first video. We don't have to show everything. We can actually streamline this, all right? So first, let's make sure we have a pattern. So I'd like to rewrite this table with repeating numbers, and I want to make sure that I have a pattern in my y values. So 4 turns into 10 by adding 6. 10 turns into 16 by adding 6. And 16 turns into 22 by adding 6. These are sequential starting at 0, so I have a pattern. They're increasing by 6, so I should have a pattern as well in the graph. So now I can rewrite my table using my repeating numbers. Remember, the first row always stays the same. The x values also stay the same. Now I need to write the value 4, or the number 4 in each row, but I have to get the value that's 10. So how do I get the value 10 using a 4? Well, it's 4 plus 1 6 will get me to 10. How many 6s do I need to turn a 4 into a 16? I need to add 2 6s. So this is going to be 4 plus 6 times 2. And how many 6s do I need to add to turn 4 into 22? I need to add 1, 2, and 3. So this is going to be 4 plus 6 times 3. And again, here are my repeating numbers. This is repeating with this. And this is repeating with this. And this is repeating with this. So we have a good pattern. We have repeating numbers. And because we have repeating numbers, we're going to be able to do what's called generalizing the pattern, which means we extend the pattern to a variable amount. Okay. So because we have repeating numbers, I'm going to repeat myself. Because we have repeating numbers, we can predict other rows in the table based on previous rows. So if I was to, again, rewrite this and have 0, 4, 1, 4 plus 6 times 1, 2, 4 plus 6 times 2, 3, which is 4 plus 6 times 3. And then we can make predictions. Like, if I want to know what's happening in row 13, I can take my existing pattern and apply it. Actually, this is row 14. I can apply it to this row. And we will get 4 plus 6 times 13. If I wanted to apply this pattern to, let's say, row 23, I would have 4, not row 23, the 24th row. I keep making that mistake. I would have 4 plus 6 times 23. And if I wanted to go a little bit further and generalize and talk about the x, or the one after the x row, this row, row x, it would become 4 plus 6 times x. So it's this idea that I just did, extending our pattern to larger amounts and eventually to an x value, is what's going to allow me to write the equation for a table. So I'm going to go ahead, set up the end of the first goal and show you how to accomplish the second goal here real quick. So let me clean all this up and I'll be back. I'm back, so let's go ahead and continue with our first goal and finish our first goal and jump into our second goal. So from the previous section of the video, we saw that this table, when we rewrote it with repeating numbers, becomes this. And once we get this repeating number pattern, we can replace a number with x and get a generalized version of our expressions. So the key idea to write equations that represent tables. We're going to replace the repeating numbers with the x and set that value in the y column equal to y. So here I already replaced my repeating values with x. This is my value in the y column, and all I have to do is set that equal to y, and I've written my equation. So my equation that represents this table is going to be y equals 4 plus 6x. All right, so I'm going to go ahead and check off our first goal, which is creating equations that represent tables, and I'm going to jump into the second goal, that's verifying the equations work. So to verify, we're going to pick an x value other than the first value, plug in and make sure it gets its output. So for example, if I plug in the value 2, I should get 16. So let's plug in the value 2. But I could have also plugged in 1, I would have needed to get 10, or I could have plugged in 3 and I would have needed to get 22. So I'm going to plug in 2 for my x, and I should get a 16 back. So y equals 4 plus 6 times 2. 6 2's is going to get us to a 12, and so now I have 4 plus 12. Put those together, that gets me to a 16. I'm sorry, I'm writing on that line. Let me erase that and write a little bit more clear. So I did get a 16, so this verifies I have a good equation. All right, now again, I haven't made this clear in this lesson, but this is a rule. Right, and you have inputs that make outputs, and remember, tables represent relations, so this relation you can also describe using equation. All right, I have one example that I'd like to tie everything together and just show you how what I expect for the homework assignment. Homework assignment, I believe it's Unit 3, Homework 5, but I don't remember. All right, so the directions for the assignment will be to rewrite the table with repeating values, write the equation, and verify. So let's make sure that we first have a pattern. I have x's that are sequential, starting at 0, 1, 2, 3. So that's not an exciting pattern here. But here I'm subtracting 3 as I move through. So I have a pattern, so that means that I can rewrite my table with repeating numbers. So my first row stays the same. I need to take away 1 3 from 15 to get the value 12, so this is now going to become 1, and 15 minus 3 times 1. I need 2 3's that I take away from 15 that make a 9 for this row, so this will be 15 minus 3 times 2, and again I have repeating values. This is good, and finally I have to take away 3 3's from 15 to get to 6. So 15 minus 3 times 3, that'll give me 6. And since I have repeating numbers, I can generalize and go down to this value. And that's going to be 15 minus 3 times x. So my equation is going to be y equals 15 minus 3x. I think I'm going to plug in a 3. That means I should get a 6. So we'll plug in 3. Should get 6. You don't have to write this, I'm just reinforcing the way that the verification works. I need to see this table, I need to see the equation, and now I need to verify. So y equals 15 minus 3 times 3. 3 negative 3's is negative 9. 15 minus 9, that's going to get me to 6. So I have a good equation that represents my table. So this is everything I need you to do for Unit 3, Homework 5. I believe that's the correct assignment. So I'm going to go ahead and end this here. Hopefully it makes sense. Hopefully you understand how to create equations that represent tables and how to verify that the equations work. So I'm going to go ahead and end this here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.